Welcome back to my Networking Basics course. There's a link in the video description below to this material as well as these labs, so you can follow along if you'd like. We're going to continue with our Internet Basics section by going over IPv4. So IPv4 essentially is a 32-bit number. We'll get into binary in a second, so don't worry about that. But essentially each device on a network has two things to identify it: an IP address and a subnet mask. Now the IP address is what uniquely identifies your device on the internet in a given network. And the subnet mask identifies which network your device is a part of. So we could reckon an IP address to something like your street address and your house number if you were to get mail delivered there. And your subnet mask would be more like the area code of where that mail would be sent before it can be distributed directly to you. Both of these are written in decimal format, and they look like this: 4 numbers separated by dots. So an example IP address would be 192.168.0.1. An example subnet mask would be 255.255.255.0. Moving on, IP classes, not something that you really need to dive super deep into, but it is good to know. There's 5 IP classes, and essentially they're just ranges of how IP addresses start, and they were handed out depending on the size of an organization or the needs of an organization. The organizations with more employees or more users needed more IP addresses. Now for IPv6 in contrast to IPv4 is a 128-bit number, which is a lot bigger. It means that it can handle a lot more users on the internet. This was created because we were running out of, and are actually out of, IPv4 address space. There's no more new IPv4 addresses being handed out. And these are written in hexadecimal format and would look like this. Now, don't worry too much about IPv6 right now. We're not going to cover it in this course. Moving on, we'll hop into a little bit of binary. So what is binary? Basically, binary is a bunch of ones and zeros. We'll say if there's a 0, that bit is off, and we'll say that if there's a 1, then that bit is on. As you can see in my little chart here, I've got 8 bits lined up, and here's the values of each of those bits, which are represented as powers of 2. So you start with 2 to the 0, which would equal 1, then 2 to the 1, which would equal 2, then 2 to the second, which is 4, and so on and so forth. Now we have 8 of them because in IP addressing we're going to be talking about something called an octet, which is a set of 8 bits. And these IP addresses are actually 4 octets separated by this dot in between. So each of these numbers is contained within one octet, or one set of 8 bits. For example, if we tried to write 192 in binary, we would put a 1 in the 128 spot, and a 1 in the 64 spot, and 0 in the other 6 spots. So 128 plus 64 equals our 192. If we look down here, if we have all zeros, obviously the resulting value would be a 0. And if we have all ones in each of those 8-bit spots, we would have a value of 255. So what that tells us is that each of these 4 numbers in our IP addresses can be between 0 and 255, because that's all that fits within one set of 8 bits. And in total, each IP address, like we discussed, has 32 bits in it. Moving forward, let's talk a little bit about networks and hosts. This is how we might further dissect our IP address and our subnet mask. So if we had this IP address of 192.168.0.1, we represented in binary right here, and then we had a subnet mask of 255.255.255.0, we could represent that in binary here. Essentially, looking at the mask, anywhere that there's a 1 would represent our network portion of our address. And anywhere that there is a 0 would represent our host portion. And when we get into subnetting, we'll talk more about this and go more in depth with it. And there's also 4 things that you'll look at or learn to look at every time you're dealing with subnets or networking. And that's the network, the first usable IP address, the last usable IP address, and the broadcast address. There will be 2 unusable IPs in each network, which would be that first IP of the network ID and that last IP of the broadcast. Basically just means you cannot assign those IP addresses to an end device like a computer or a printer or something like that. And there's also 2 special networks throughout our IPs that we'll go over, which is 127. Anything that starts with a 127 would be considered a loopback address. Basically, the loopback is so that your device can test that its networking card is functioning correctly. That way you can rule out your device and the physical connection to your device as being an issue when troubleshooting. The next special network would be starting with 169.254. That's what's known as an IPV4, or basically a privately assigned or automatically assigned address by your device to itself. This is done so that it can still communicate within its local area network, even if it fails to get a properly assigned IP address from something like a DHCP server. So that was our basic rundown of IP and IP addresses. There is a lot to learn about these topics, and I highly recommend you go out and study more on your own until you feel more comfortable with them. It's absolutely crucial in networking to know these things. Our next video coming up, we'll be diving into subnetting. I hope you stick around for that, and I hope you enjoyed.